ಸಿಂಗಲ್ ಅದೇ లాస్ట్ ఎస్కేప్ నేను ఎప్పుడు ఇంకా అవ్వలేదు కదా స్టిల్ జరుగుతుంది లాస్ట్ బెటర్ అందరు సైకిల్ నది పోరాడు అందరికి వెయిట్ అవుతారు నేను ఫోన్ చేస్తా
Sir, good afternoon. కడుపులో కూడా కరోనా ఏ రోగం వచ్చినా ఫస్ట్ కరోనా టెస్ట్ చేసుకుంటాం. వస్తుందంట మినిస్టర్లకు వచ్చిందంట. అదే ముంబై మినిస్టర్లుగా వచ్చిందంట. వచ్చిన వాళ్ళకి వాళ్ళ పేరు కూడా చెప్పారు. వాళ్ళు ఏమన్నా సాగనంపడానికి రెడీ అయినారేమో. Sir, good afternoon.
Good afternoon, Dr. Reddy.
Sir, how are you?
Very well, very well. I'm glad to be having this discussion today.
Okay.
I hope my voice is clear.
Yeah, yes, sir.
Okay, great. Thank you.
So I'll wait 5 minutes.
Sure, definitely.
It's less. ఖాళీగా ఉన్నారేమో. ఏమరైతే ఓకే నిజం చెప్పినావనే. దానికి నేషనల్ ఓషన్ టెక్నాలజీ పంపిస్తున్నాడు. వేసిన చూడదాం లేవు. ఓషన్ టెక్నాలజీ ఉంది పీపీటీ. పీపీటీ కూడా ఉన్నా. పీపీటీలన్నా పెట్టుకో. పీపీటీలన్నా
ఏం
పెట్టుకో.
చేస్తున్నారు మనం చెప్పాడనే వాళ్ళు చేస్తున్నా
అంటే అప్గ్రేడేషన్.
అంతా బేసిక్ అయ్యా
మొన్న ఒక రోజు కడుపు అంతా నొప్పి, నైట్ నిద్ర లేవు. ఇది మూడోసారి నాలుగోసారి పోతున్నా సాయంత్రం.
40 వచ్చావు కదా,
ఆ?
40 వచ్చావు కదా,
పోయితే ఇబ్బంది లేదంట.
ఎంత పోతా అంటే ఏం తిన్నాను
Sir, shall we start, sir?
Yes, certainly, absolutely.
Yeah. So, good afternoon to the today's speaker, Mr. Piyush Jaju, sir, and my dear participants. Welcome you all for the 2-week online faculty development program on renewable energy intervention in industry, commercial, and domestic application. So today, sir is going to deliver a talk on decentralized smart solar technologies through IoT, solar lighting, irrigation, microgrids, and rooftops. So before handovering the session, I would like to introduce the today's speaker. So Piyush Jaju is a co-founder and CEO of Onergy, one of the leading and multiple award-winning social enterprise promoting complete solar solutions. So Sir has been recognized among the 100 most powerful leaders in the solar industry. So Sir is an economist, graduate and university topper. Sir has prior experience in financial services and investment banking within India, Hong Kong, and Southeast Asia. Sir has received prestigious international fellowships from Santa Clara University in USA and Unreasonable Institute USA. He is a regular speaker at various national and international forums. This is the brief and short introduction about the PS Jaju sir. So with this, I request Piyush Jaju sir, please deliver the talk.
Yes, thank you so much, Dr. Eddy. I hope my voice is audible, and I think it's a real privilege to be talking to a very esteemed and august gathering. I'm grateful. At first, I was a little hesitant if I would be the right person to deliver the talk. Maybe I'm a little too underqualified, I think, just having done a bachelor's in economics, leave alone doing a doctorate. But nevertheless, I'm very keen to share the experiences that have happened since I've been associated with the solar and the renewable development, renewable energy industry for the past 12 years. So I'll quickly share my screen.
Yeah, please.
I hope the screen is there for all. So what's very interesting, I'm definitely, I think I'll try to make it as interactive as possible. Please feel free to cut me and stop me. I can understand it's a post-lunch session and it can become very difficult. I personally myself feel quite sleepy after having lunch, so I can understand with the work from home condition and a lot of people getting locked down. So let's try to make it as lively as possible and as interactive as possible. But especially when we come about talking about everybody right now is talking about smart. That's become the main buzzword. We discuss about IoT, AI, ML at the drop of a hat. It's just like talking about any other things. That's what we think about. And particularly, things have changed so much over the past few years. Especially while we were in school, we used to talk about watching National Geographic and watching the python snake. And right now, people in school talk about a different python. So that's a big difference between what we used to discuss and what kind of a python that people discuss about. So that's what first I would like to share, especially on how IoT is really transforming the renewable energy industry. Right from when we talk about from generation, transmission and distribution, to demand side management, to also looking at the entire regulatory framework. Everywhere there will be disruption with new technologies that are coming about. And it's very important for each one of us to be up to pace with these smart technologies, which is going to transform the industry at large, not just renewable energy as a matter of fact, for any kind of industry. But especially as faculty members, it's very important for us to stay up to date with how things are happening. There have been large level, as we all know, one of the main, although renewable energy has a lot of promise, the but at the same time there are some limitations, both in terms of how much generation is possible. There are risks in terms of other adverse weather conditions, how we are able to do better load management, given that if when we are talking about a large focus on solar generation, but at the same time it's important to do better load management, energy management, given if there is too much pressure on the grid, especially during the daytime, how we are being able to manage that in a more efficient way. Similarly, how we are being able to optimize the grid with renewable and non-renewable sources of technologies. Along with it, with the big focus of the government of India towards going for smart grids. So how we are able to integrate renewable energy technologies with smart grids for better load management, even going to individual respective homes. Now again, we are talking about smart mobility when it comes, because as we all know, a big focus going towards electric vehicles. But everything, it's important that we look at how we can not talk about these things in silos, but we are able to talk about in unity, a way in which everything can be done more seamlessly. That's where smart technologies will have a very, very critical role to play in order to integrate the entire value chain that goes about from renewable energy, right from generation to using to the end user, along with how we are able to better regulate and monitor this entire value chain. So the first step definitely is getting into IoT. By IoT, okay, we are able to do better analytics, we are able to capture better data, we are able to do it remotely. We are at least able to do a lot of things right just by integrating simple IoT into the entire renewable energy value chain. Now, going forward, the very critical part would be how we are able to then, from IoT, we are able to integrate artificial intelligence and machine learning also. That is going to be the real game changer going forward, when we are able to better predict, when we are able to have better algorithms for how we are able to analyze the all so much data that is getting captured, and through we are able to do better forecasting of all the data which is there, in order to really reduce the risks that come about when we talk about renewable energy, because that is something that we have to take it for given. The sun is not going to shine brightly every day. The stream of water will not be consistent every time. And so will be the wind. There will be large variations, and especially when we are talking about climate change, going to absolutely create havoc. So at one side, we are fairly certain that climate change is going to play a huge role, which will alter wind patterns, which will alter conditions of the sun, of the rivers, of everything. And if that is going to have such an adverse impact on renewable energy generation, then what can we do by developing better algorithms, by developing better models for wherein we can create automatic learning for better prediction of our weather, of on the historical data. But on the historical data right now, a lot of times it becomes irrelevant, because at the rapid pace at which the climate is changing, so it's not just, we cannot just depend on the previous data that has been captured, but really being able to predict the right kind of weather conditions, what could possibly alter or affect renewable energy generation, and then how we are able to counter that well in advance, and we don't have to wait for a catastrophe to happen in order for us to open our eyes. So I think especially the big change would come about with the integration of artificial intelligence and machine learning, which can really totally create a new dimension to the way that current technologies and business models are being looked at across the renewable energy value chain. Going on, so what I would like to do is that particularly for the point of discussion for today's presentation, I would particularly like to share my experience, talk about practically what we've been facing on the field, especially over the last decade or so, and I would particularly like to give some specific examples on the different technologies that we have been engaged with at Onergy through multiple various international collaborations that we've done that are working on smart technologies, and how we are being able to effectively deploy it to the field. As an organization, we are focused on decentralized distributed generation, largely of solar. And particularly when we're looking at these decentralized solar applications, how we can make those more smart. So especially when it comes about what are the main problems that we face when we talk about decentralized energy systems. I'm sure I don't need to explain what these decentralized distributed solutions are, but essentially largely we are talking about systems which are directly, be it solar rooftop systems, even though it is grid connected, but we are able to generate energy in a decentralized way, to remote applications, even for rural areas, be it for water pumping, or be it for village electrification, or be it for just simple as solar lighting. How these can be made more smart. And that's where, when we first analyze, I think a great way to look into is that first, let us understand what the problems that we face when we discuss about all these decentralized energy applications. One of the biggest hindrances is that, we're talking about, very small level applications, small level technologies. These can be it can be as small as a solar lantern, which just cost a few ₹1,000, to going into larger lighting systems, maybe street lighting systems or high mass systems that goes into, again, maybe 20,000-30,000 rupees. Then we go into a few lakhs, which can be solar water pumping. Then we look at maybe larger systems, which is microgrids, which can again be a few lakh rupees up to 50 lakhs or about 1 crore. And then we look at larger, maybe rooftop systems, which can go again into crores. But again, over here, when we're talking about these small solutions, then it becomes so difficult for us to understand if these systems are working well or not. Because one of the biggest challenges when we started with Onergy about 10-12 years back, one of the biggest issues and problems that we faced when we spoke about these decentralized, even say solar lighting systems that we started with, there was a very, very big trust deficit when we talk about going into remote villages, or even, as a matter of fact, even in cities. People used to question, does it really work? Or there was common inferences that, maybe this solar light was installed, or this solar pump was installed through some government program. It worked for a few days, for a few months, and then it stopped working. And we don't know what to do with it. Now sitting over here in my office, I can look to monitor on a single dashboard. I can look to monitor thousands of solar pumps that we have installed. Because each of these pump has a remote monitoring system wherein we can understand if it is working or if it is not working on what has to be done. So sitting in your office, one person is able to monitor thousands of sites, small sites, just by simple IoT integration. So that's where the problem about how we are able to overcome this trust deficit, how we are able to use that data to a more meaningful use, just by capturing various inputs in terms of the power generation, the voltage, the water that is coming about. Through all those things, all the data that is getting captured, all those inputs, that how we can put that to more meaningful use to understand if the system is working well or not, or what may be the problem, where exactly the problem lies, how we can specifically in a very targeted way be able to address this problem. I remember in the past days when, say, a light used to stop working. I'm based in Calcutta. We've done so many projects in Sundarban region. We used to get calls that, okay, that this system is having problem. And maybe the local technician, which was there in a Sundarban island, that was not able to fix it. Oftentimes, what used to happen is that we did not understand what exactly was the problem was. So one person, if the problem was not able to fix at a local level, then one person had to travel about a distance of, say, 150 kilometers. It used to take 4 to 5 hours to cover. You had to first take a train, then a bus, then cross a river, then take a van, then again cross a river, then again reach to a village, there again walk down for some time, and then finally reach a point where this renewable energy light, a solar light, was installed. And finally, once you reach there, a technician that reaches there finally realizes, okay, this is the problem. Maybe just there was this mouse that bit the controller. So ultimately, the controller will need to be replaced. And that technician was not carrying a new controller. So again, you go back. After maybe a couple of days, again, you have to go back with a new controller and change that controller. But say, if now with the penetration of data, you're able to, even though you may not have electricity in a village, but still you would have a phone connection, you will have data over there. So through that data, even if the system is not working, but by sitting in my office, I can understand where exactly the problem may be and what could be a potential point when we are able to get that kind of data, and then how we can solve it. So that's a big change that has happened. We are able to really shorten the response time. We are able to clearly understand where the problem may lie. And then specifically, more importantly, we are able to build trust with the end user that, okay, these systems actually work. There may be some internal problems, or there may be some external reasons why there has been failure of the system, but one can definitely address it when we are able to remotely monitor those sites, when we are able to properly understand and more importantly, remotely diagnose what the problems are. So that's how, especially just making through IoT devices like remote monitoring and control, how we are able to understand and really and really make a big difference. So this is where I would like to discuss about the remote monitoring and diagnostic part that we are now integrating with all our systems. That happens, be it with lighting or water pumping or various other things. So here, especially what we've done, we've collaborated with a German-based company called Ferntech, wherein we are using their what they call as a universal monitoring controller. So what does the universal monitoring controller do? Is that it's a remote monitoring device which can be added on with any other controller. You have controllers for pumps, you have controllers for the microgrid systems, or you have inverters. So through developing the APIs, you're able to connect with the controller of the system, and then you're able to monitor all the aspects of the generation and the usage of the system. which is there. And ultimately, all that gets stored in a cloud through which in one central dashboard, we're able to monitor all the sites. So such kind of a remote monitoring and diagnostic device is the example that I was given with. So here what we do is that we just use any particular GSM based SIM which has data connection, which gets added on with this universal monitoring controller. And ultimately, we are able, with very little human intervention, we are able to monitor all the sites in a proper way. Now, in one simple way, one something for the universal monitoring controller, one simple thing can be, for example, just say a solar irrigation pump. We are just integrating with a solar irrigation pump. We are able to understand what has been the discharge of water every day, what has been the energy generation which is coming about. If based on that, we are able to directly understand with what should actually be the solar irradiation based on that place, and if it is optimally generating or not, or if there is some problem, we can really understand where the problem may lie. If say one day we are getting very little generation, very little water output coming from the pump, we're able to understand, is there a problem in the string in which we have connected different panels, or is it a problem that with the pump that the motor has got jammed because all the mud has got filled into the motor. So through those specific, by understanding capturing the various inputs which are there that is coming from the controller, we are able to adequately understand where the problem may be, or how we can optimize the generation. So that is something simple when we just talk about a simple irrigation pump. When we come about with a microgrid, then along with a microgrid, like recently we have one project going out in Sundarban region only, wherein we are in near the Tiger Reserve Forest, we are doing a project for WWF of setting up a village microgrid connecting about 200 households. So here the microgrid is connecting different households, shops. There is also a diesel backup generator which is there along with the solar system. So you need to look at managing different loads from solar. When can the DG set automatically kick in if the battery voltage is going down to a certain level, or if there is not enough charge in the battery. If there is, it can really understand if there is excess. Maybe if somebody is wanting to steal the power by hooking into these distribution boxes which are there, and somebody is wanting to draw out excess power in their homes or from the transmission lines, that can again be understood through remotely to check if there is some loss of energy either from the transmission level or actually at the home, if somebody is wanting to bypass the fuse and wanting to connect some extra load. Maybe somebody's got interested, maybe somebody's got a new TV and without any kind of an information wanting to run that TV, we can definitely, through those things, we are able to understand in a better way. So this is how, this is what really the remote monitoring controller does. First, in which a very important part is we are able to get results sitting in our office here in Calcutta. We are able to troubleshoot problems. We are able to really understand how the system has been performing. Now, going forward, what are different things that can be incorporated? We can definitely reduce any kind of troubleshooting issues and can look to solve more issues locally by understanding where the problem is and then directing the local technician. Especially, we can see if there is any loss of generation, what could be the problem. And then finally, the more important and interesting aspect will be that once we've been able to capture so much data, how we are being able to incorporate artificial intelligence into these remote monitoring devices, so that it can really optimize that entire system. It can predict any problems that may occur, or really look at for us to help in designing better systems going forward. So this is how we see future developing by incorporating right now with a simple IoT device, but especially AI can really look to make a big change to this simple remote monitoring device as well. Now let me talk about some of the different technologies that we are implementing, and then how we are being able to make it more smart. I'm sure you've all seen solar rooftop installations which are going about. Now, what can be done in order to make these solar rooftop installations more smart? Now, especially there have been companies, manufacturers that are developing smart inverters in order to enhance the safety level. If there is any say shutdown, or if there is any excess, if there is huge voltage fluctuations, then through these smart devices, you are being able to better manage any faults that may occur, and then automatically shut down the system, or to understand how it can predictively, you're able to optimize the energy which is coming about. Especially when we are talking about now, these are centralized inverters, string level inverters. There are also micro level inverters through which we are able to monitor generation from each solar module, and to able to understand if there is any hotspots which are being generated, if there is any shading that is happening. Because as we all know, even if one module is partially getting shaded, then it affects the generation of that entire string in which it is connected. So even getting to a level wherein we are able to monitor generation from each module through these smart micro inverters is going to really bring about a big change. Of course, right now the cost is a little bit more prohibitive in order to monitor each and every module through these micro inverters, but definitely going forward, we see that as a big game changer once the price starts coming down. So that's more about how we are able to make inverters more smart. Secondly, it's about, again, utilizing these remote monitoring systems in order to adequately understand, operate the system, and then adding an AI level going forward. By AI level, we are able to properly capture, again, the irradiation level, the weather impact. If there is any, we are able to model out if there is any shading happening, or if there is any other obstacles which are there, at what time cleaning will be required if there is more dust accumulation. So automatically it throws out more alerts that based on, so there is reduction in normally in the energy which is generated from the modules, which is most likely the cause wherein it would require cleaning, which can then increase again back the generation. So all those things we're able to utilize through better predictive models, through better algorithms. If in future we have to definitely look to design, definitely these things are still not there more efficiently. But it'll be very important to understand how automated cleaning can happen based on if there is dust accumulation, and those kind of modeling is done just so that the generation can be increased manifold. Because it's very pity, because when we just go across, visit so many of these rooftop systems, most of it, I would say, is operating at 30 to 50% lesser capacity. Why is there so much loss of energy generation? Just because there is dust which is accumulated on the modules, and nobody is even so much bothered about cleaning it regularly. But if one is able to monitor it properly, you can just use on your phone. One is able to understand, okay, this has been my energy generation, and if there is a dip in generation, then what am I have to do? is there a problem of dust, or is there a string level problem, or is there a hotspot problem, or what exactly is the problem, we are able to understand and then properly address it. So these are things that is ultimately going to bring about a big change in the solar rooftop systems by making it more smart. Of course, for the larger level rooftop systems, then we have to look at monitoring through SCADA. That's where we have, say, it's even for a rooftop system wherein it's distributed across multiple buildings. There is, say, a 1 megawatt installed, spread across multiple, definitely, which is there across in many institutes, the institute having many buildings, various different solar rooftop systems installed across different places. Then through a centralized SCADA level monitoring, we are able to understand the performance of each of these rooftop systems at different sites which are there, and able to centrally capture all that data and monitor that. Of course, now there are more solutions wherein you don't even need to look at a centralized monitoring. There are also cloud level solutions wherein you can have SCADA on the cloud and you're able to monitor your plant level performance across various different sites through it, and can be done in a better way and fashion. I'll move on. So this was something more about rooftop systems. Now, I just want to discuss about how even a very simple solar street light, something which is costing, say, 15 to 20,000 rupees, how that also can be made, how that is becoming made more smart. So, of course, we had those motion sensors which have been there for more than 5 years, in which you're able to optimize on your solar panels and your battery systems which are there. So it's very interesting, this is how just through better motion sensors and with better timers, we're able to really bring down the cost of this solar street light system. Earlier, as people who you all may be aware that earlier, just for powering, and this was even guidelines of Ministry of New and Renewable Energy, even say 5-6 years back, just for powering a 11-watt light, we had to give a 75 watt solar module and a 75 ampere hour battery, just for 11-watt light. But by building better motion sensors, or building better timers based on if there is drop in voltage, so that there is a dimmer which is there within the light. So that 75 watt modules and the 75 ampere hour batteries, we're able to, for 11 watt light, you're able to even provide a 35 to 40 watt module. And by using lithium ion batteries, even a 20 ampere hour battery is good enough. That's because just by incorporating simple IoT level sensors, which have been there, and you've been able to program that light. That hardly costed maybe a few hundred rupees. Just that simple small innovation of few hundred rupees is able to bring down the cost of this entire system by about 30 to 40%. So at one level, it may sound so simple as a solar street lights, but it's having such a big difference. Just instead of by changing these lead acid batteries to lithium ion batteries. Because so many times, even if you're going in, you may be seeing that maybe in railway crossings or so many places, these street lights have been installed, standalone solar street lights have been installed, and a lot of times it is not functioning. Why is it not functioning? Because once it was installed, many times it was these lead acid batteries which require regular maintenance. You're not able to either provide the right kind of maintenance, or these batteries were installed down, and somebody has just stolen the batteries. Now you have integrated street lights wherein the batteries are fitted along with the light. So it's not so easy to steal those batteries, because one will have to climb really high up and then have to open up the entire light and the battery in order to steal it. So it's made life little difficult. So those kind of innovations is where simple innovations that we look to think about in order to make solutions more efficient. Of course, how we can take it to the next level. Again, over here, remote monitoring can be established. Remotely, we are able to understand if the lights are working or not, just by having a simple controller which is there connected with a GSM based SIM. So remotely we can understand if the lights are working or not, or how we can solve if there is any problem. So the remote management is something which can be integrated, although definitely right now even a simple remote monitoring system right now is costing a few thousand rupees. But then again, that can have such a big difference when we are able to integrate all those solutions. One can even integrate cameras into these lighting, into the street light system. So you're able to even through cameras, one is able to understand by sitting in my laptop over here. I have a camera installed along with this solar street light, and I can understand what is going over there. So those are again incorporation of better smart ways in which we can really make these street lights much more effective. Now, going to the point of village electrification through the solar microgrids which are there. Of course, when we initially used to install these microgrids, it was just something very simple. You have centralized either DC microgrids or AC microgrids, in which you are just powering the entire village which is there. And we've seen there were so many challenges that used to happen because Jugaad works so well even in villages. Somebody will figure out a way in which how you can tamper with the system, or you can connect different loads to it without any information, or there may be some other ways in which directly somebody is plugging the battery and powering some devices bypassing the controller. So there were so many different things that were happening. But really, when you're able to make these microgrids smart, it can have such a big impact by using prepaid metering, by using prepaid meters, smart meters. So one would able to understand that, okay, if there is any theft at a household level, and the lights automatically go off, because we're talking about these prepaid meters which have been installed, and you will have to pay in and punch a code in order to reactivate the system if it's not if you've not charged and paid for your for the connection, the household connection which is happening. Through centralized remote monitoring, we are able to understand what the generation is and be able to do better energy management and load management. There are also battery management systems which are there in order to more effectively ensure that there is no deep discharge of the batteries, and how we are able to better manage the batteries which are connected in series and parallel, which have been ultimately installed. And ultimately, that just overall increases the life of this entire system. It makes it more foolproof if somebody is wanting to do too much of jugaad and tamper with the system. And overall, you're able to better operate it and better diagnose any problems that may happen going forward. One of the very good examples is that this company called Sun Moksha, they've gone one step beyond by developing a smart microgrid. So this is in one of the villages in Odisha, wherein they've even given out, along with just transmission lines going on top, they've even put in optical fiber cables connecting different households and the marketplaces and everything which is there. So going pretty really high tech, along with adding different smart sensors from better weather monitoring to soil monitoring, to different other sensors which have been installed. Along with it, you are being able to integrate your school, the local hospital, which is there. Each and every household is well connected. There are these energy cards, and so one person will have to go from village to village. If there is deactivation, if somebody is not paid, then you go about and reactivate through this mobile app, which has been there. And these are certain things that definitely is the future of how microgrid systems would be looking to do. So many of these digital services which are getting provided when there are these ICT center, which is there powered by solar, wherein you are being able to provide these digital services getting at a village level. So this is kind of one of the examples, and you're able to monitor the entire plant performance along with the system which has been installed. Now, let me come back with especially on some smart solutions that we've been looking at across the agri value chain. Really, one of the main essence projects that we've been working on is that how we're able to decarbonize the entire agri value chain, and what are the key interventions that we are doing in order to make it more smart. So one of the important aspects, especially, is that first to do a large macro level assessment of where renewable energy and smart technologies can have the maximum impact. So with GIS level mapping, and it's wonderful that we are able to even, there are now policies coming about wherein you're being able to even reduce your regulations on maps, which was recently also announced by the Prime Minister. So those things will be very, very essential and very helpful in order to do a large macro level assessment through GIS, wherein we can understand which are the specific ecologies, which are the specific areas that have to be addressed. So first, we go about through GIS doing a mapping, say, of the entire state, and identify which are the key belts. Maybe first, which are the key horticulture belts where there is deep penetration, which we should be addressing through these different agricultural smart solutions. So that's one way in which we've been using the GIS maps. There's a company called Progress, which is based out of Romania, who's developed some wonderful GIS mapping tools through ICT, which is really able to assist with precision farming. So there, particularly, one of the key interventions is we are able to identify through satellite images, able to understand and study the entire farm which is over there, how we are able to optimize at a macro level the areas which are being covered with different interventions, and then come up with the right kind of solutions based on the data that is getting captured through this through the software tool which is incorporating GIS mapping. These are one of the examples on what kind of images which are getting captured, and then specifically how you're able to address those particular issues. Now, from a macro level, let's go down to a micro level. Let's look at how we can use drones to really understand and analyze at a farm level how it's happening. So the solution is simple. You're mounting a multispectral camera on a drone, and the drone is being used in order to do the entire assessment of the farm. So what it does is that through the spectral images which is captured, one is able to monitor and understand from at a soil, for soil, the plants, the status of the plants, and even the solar cells, which are through the spectral images one can able to understand. And especially there have been very significant ways in which there are, it's really amazing, if just through these different images, the amount of information that one is able to gather and understand, what the level of soil nutrients which are there, the moisture level in the soil which is there, how healthy are the plants which are being grown, is there any problems with the solar cells which are there. So just it's practically it's so difficult to see, to go around the entire acres and acres of area which are there, but especially drone can assist with getting the right kind of information which it comes about. And ultimately this is where it really helps with better, in order to automate farm level mechanics and also do better precision farming when it comes, once we are able to analyze. So a software has been built which can understand and read all these spectral images which are getting captured, and based on that we are being able to provide the right kind of inferences and the different interventions which is required, and ultimately that's what will lead to greater agricultural productivity. It's very surprising, that productivity which is there, and what are the different ways in which we are able to really enhance through these smart technologies which are there. So these are some of the cameras which are installed on top of the drone, and through which we are able to capture these high resolution images and spectral images, which are then ultimately analyzed to improve better farm management and to also enhance productivity, and in order to pinpoint the right kind of interventions that are required for better crop management. If there has been any for, be it pest management, or if there has been any loss of nutrients which are there in the soil, or if there are any problems which may have a big adverse impact on the ultimate productivity, those are things that can ultimately be addressed through these issues. Now, let's come to these things on the water pumping, on the solar irrigation front. These are certain initiatives that we have been taking in order to make it more smart. Of course, a very simple thing is that, okay, we've been installing these remote monitoring system through which we are able to operate thousands, we are able to understand and monitor thousands of solar pumps that we've installed. But right now we are piloting and we're taking that to a next level, wherein through better drip and sprinkler integration with IoT. So what exactly does this mean? So here we are installing moisture level sensors at each node, at each pipeline which is there. We program the device to understand if there is a drop in moisture level of the soil below a certain level. And once it crosses down to a certain level, the moisture level, then automatically the IoT triggers water flow into the entire drip system so that optimum irrigation is achieved. So normally, as we know, that drip and sprinkler based systems are able to reduce your water requirement by 50 to 80%. As compared to a regular drip system, the automated sensor-based drip system can further bring about more 25 to 30% efficiency. So overall, we are talking about, as compared to regular flood irrigation, we are able to achieve more than 90% efficiency in our water usage when we are able to combine it with moisture level sensors and and then ultimately automate it without any human intervention on when we would need to switch on the drip or switch off the drip. We are not doing any kind of over irrigation, and everything can be run so much more seamlessly. So this is something which can really have a impact to transform the entire irrigation space, which we are very keen to develop. Another level wherein we are also collaborating with an Italian company, wherein they've come out with an app which is called Y for Agri. So overall, the understanding is that through app we are able to better monitor the irrigation level, how much fertilizers is being used. So better water management and better fertilizer management is what we are able to achieve through the app that has been there. So what we do is that we integrate this app with the regular solar water pumping system, or even the automated sensor-based drip system. And ultimately, the app throws down very important feedback and data in terms of, with the help of various sensors that have been deployed to understand optimizing both the fertilizer requirement and the water requirement, which would ultimately significantly enhance the productivity of agriculture, but also save on the input costs which are required. So these are particularly solutions when we're talking about, these are just not simple R&D solutions or for the sake of making smart, but ultimately all these solutions will also need to have better unit economics and cost economics if we have to scale. So until unless there is a clear financial benefit that one may get, it's no point developing these technologies. And that's why even with making a small investment in the app, in these automations, what it really helps to do is the amount of savings that happen in the input costs. If one is able to save 50% more on the fertilizer costs, if one is able to save on the diesel costs, on the electricity costs by going solar, and reducing and optimizing the design. So maybe what we've seen is that a 5 HP pump, which required about 5,000 watts of modules, we are able to reduce by better management. A 2 HP pump is able to meet the needs of a 5 HP pump. So we're talking about more than a 50% more energy efficient system, which is overall bringing down the cost of the system, just like the case that we've seen in solar streetlights, which has significantly scaled up. We are wanting to build that same inference and incorporate that to solar water pumping. How can we just make the system more smart and more efficient in order to reduce the entire energy requirements by more than 50%? And overall, bringing a drastic reduction on the overall cost of the system and the overall economic and financial viability. So this is the way in which we are able to make it much more affordable and accessible even to small and marginal farmers. So it does not mean we're not talking about, these smart applications are for the rich, are for the rich farmers, are for the large corporates. These solutions, how we are able to make these solutions even for a smallholder farmer. That is a challenge that we have to look to address and solve those challenges. So through the Wi-Fi for Agri, better able to reduce on the pesticides, better weather management can be done along with it, and then you're able to throw alerts if there is any wastage or if there is any disruption in the produce which may happen. Now, I'd just like to come about with what kind of an ecosystem that we can build through the smart technologies. So here, so we have to look at, it's very important that we look at in a very holistic way, especially if we have to promote and accelerate deployment of these smart technologies. Alone, a system or a hardware or a great smart product will not solve the purpose. We have to look at what are all the stakeholders, what are all the ecosystem players, and across that entire ecosystem value chain, how are we being able to leverage IoT and smart technologies in order to make it much better. So I'll give you some examples of what we've been doing. We've recently partnered with multiple banks that are ultimately able to, say, finance a smallholder farmer. Now, a smallholder farmer can buy a solar water pump, say, which costs 3 lakh rupees. Now, when we went to the bank said, oh my God, this is a too risky thing. I have a farmer, say, that is earning 5,000 rupees a month. And now you want me to give that farmer a loan with which he or she will be able to get a 3 lakh rupees system. I mean, I don't know how am I going to get the payback of the loan, or the loan may get bad. I've seen so many cases wherein I've just given a, say, a 40, 50,000 loan for a diesel pump, and that farmer is not able to pay for a 50,000 loan for a diesel irrigation pump, and you expect me to give a loan for a 3 lakh rupees solar pump. So that was the first feedback that we got. Now, what could we do in order to make it more smart? So what we did was, with the support of Yale University, we built a tool to clearly give feedback on the bank on how the cash flows of the farmer will look like by adopting a 5 HP pump, which costs 3 lakh rupees. So we put in inferences of how much the existing produce, the value of the existing produce, what can be the improvement in agricultural productivity. Currently, from doing 1 cropping cycle of monsoons, you can do 2, or you can even do 3 cropping cycles. So that will ultimately lead to greater increase in income. Better water is also ultimately you are able to grow more crops. So overall, how will the cash flows look like before setting up a solar water pump and after setting a solar water pump? So by simply putting some inputs into our tool, a bank manager is able to assess if that farmer should be given a 3 HP pump or a 5 HP pump or a 2 HP pump. What are the crops that the farmer is growing? How many cycles will the farmer be able to do? And ultimately, if that farmer will be able to repay the loan or not. So this kind of an assessment tool, by putting the different inferences and automating the requirement for a bank manager in order to do assessment for this kind of a smart technology, that's right now becoming possible. And right now, over 400 bank loans have been deployed for the systems, and out of those 400, right now we've only faced problems with 2 defaults. So I think that that's a very big achievement, especially because earlier there were default rates which of the DG pumps that used to go down to about 10%. So if one were to give loans on 400 diesel pumps, typically you would have 40 non-paying customers or NPA accounts, and that 40 right now is just 2 when you are being able to develop this tool. Again, other thing that we are looking to do is developing a lot of online curriculum, training videos, and we're building a platform wherein especially which would help farmers. There are also other interesting companies like Digital Green that have already created a lot of content which can be used by farmers in order to better understand the crops that one can grow, how can troubleshooting areas, tools for understanding the requirements of the site at a site level. So all those automation and training capacity building tools are being put together on one platform in order to better assess the end users which are there. Along with it, there are also very interesting market linkages. There are many agri-tech companies that are working on various platforms for linking the produce to markets, which are there. which is definitely being very helpful. And more importantly, how we are able to make it much more climate smart, climate friendly, and more sustainable. The other important thing is also how we are being able to address the other largest stakeholders, which are, be it the policymakers or be it the ADAs or the DDAs at a district level or a block level, how we are able to get better MIS and tools in order to understand what are the different schemes which are there, how we are able to monitor the performance of the deployment of these different schemes, and develop IoT tools for management of the various government functionaries from a block level to a district level to a state level and ultimately at a central level. So these are important solutions wherein we can leverage on IoT to address challenges of our ecosystem and build overall capacity within the entire framework with which we want to promote these renewable energy applications. So this was a little bit about my experience and how we've been doing. I think especially it's so much more important at this age in order to unlearn and relearn. Although I've been there in the renewable energy industry for about 12 years, there are so many new developments happening every day. It's so much more important to understand, to be abreast with technologies that are there, what new things are coming, and how those can be incorporated in a more meaningful way in order to have overall social impact. And I think the same goes for each and every, there would be faculty members over here, or there may be other aspiring students, PhD students or other things. So I think the really big, large, important key with with so much of excess information, so much of excess data, liberalization of earlier rules that were there, and so much more important to stay tuned with the latest developments that are happening. And that's when we can have a lot more meaningful discussions with students, with our peers, on how we are able to contribute to build a better tomorrow, to build a more smarter tomorrow. So yeah, that's what I would like to end my talk. I will be happy to take up questions, or if there would be any issues, I'll be more than happy to take that up. Thank you so much for listening very patiently. I hope it has been interesting, or maybe I hope it's not been so boring. I didn't get any questions, but I'm really looking forward to more interactions with this group.
Participants are requested to unmute yourself and I can interact, or if any clarification is needed, so please interact with the Piyush Jaju sir.
So I've also have my email. Maybe I can also put it on the chat box. I'll be more than happy to take any questions online, or if there is any ways in which somebody is looking to do more research studies or more collaborations with our enterprise, or if there is any way I could be of help or my team can be of help, we will be more than happy to do so. So please do reach out to me. I'll be more than happy to see how we can possibly collaborate either in some research activity or in some kind of a study activity, or if we have to on better way in which we can accelerate deployment of these new technologies which are there. So I'm really looking forward to interactions with you.
Any questions from the participants? Okay, sir, we are not receiving. So, okay, sir, we are not receiving any questions from the participants. So, we are going to conclude the session. So, thank you very much, sir, for accepting our invitation to give an expert talk. And also, you helped a lot in this faculty development program. And you have given a wonderful session how the IoT technology will be useful for various in various aspects. So hope this will be useful for the participants. Thank you, sir, once again.
Thank you. Thank you, Professor Reddy, for inviting me. I think it was a real privilege to take this session. Thank you so much.
Thank you, sir.
Yeah. Bye-bye.
వీడియోస్ మీది మ్యూట్ చేయండి. మీది మ్యూట్ చేయండి.
And the co-host ఎవరికో అయింది నీకు రాలేదా వేరే వాళ్ళకి పోయింది So dear participants, the first session in the afternoon is over. The second session is virtual visit of solar thermal lab, so which is going to deliver by Professor V. Sivardi sir. So now I request Professor Sivardi sir, please deliver the virtual lab.
మీది మ్యూట్ చేయండి. లేదా సౌండ్ తగ్గించండి. Yes. Okay. The second, good afternoon to all. The second lab visit, first lab visit, we completed soya milk lab and production of soya milk and soya paneer also we experienced. The second lab available at RGMCT is solar radiation measurement and solar dryer lab. Both labs, measurement of solar radiation equipments and solar dryer. Generally, what is the purpose of solar? Why? Because solar is very intermediate nature. Latitude to latitude is changing, and due to the high absorption rate, due to the dust available in the atmosphere or pollution available in the atmosphere, diffusion of radiation is taking place. This much of the uncertainties are available in solar. Even though we are interested on solar, just about 5 minutes I will show a rough figure, then directly we'll move to the lab. This is the Indian electricity scenario. You can see from 1950s we have only 1500 megawatt capacity. At present we reached 3,74,000 megawatt capacity, but our needs not fulfilled. According to GDP 2024, our capacity is required 5 lakh megawatt power generation capacity to fulfill our needs. Then what are the sources available? First one, hydro, why? Because very good, why? Because we can do reservoir thing, and agriculture also, we can enhance the agriculture activities also. But what is the maximum capacity available in India? We can install maximum capacity we can install is 1,48,000 megawatt capacity only we can install. Up to now we installed 45,000 megawatt. Means maximum scope is 1 lakh megawatt only. But our need is increasing more than 1 lakh. And also, recently in Uttarakhand, due to the floods, sudden melting of the ice, total powerhouse itself blasted. So hydro construction not that much of easy. If anything goes wrong, means villages will escape from our map, Indian map. So that much of danger thing is there. Even though we are facing that much of danger, maximum capacity we can move only 1 lakh megawatt. Next, coming to the wind energy. Okay, we will move to the wind energy. What is the maximum capacity is 48,561. We already installed more than 30,000. There is no less. There is less scope. One more is bioenergy. That is also not sufficient. At present, Indian 1,000 megawatt. So our needs are lakhs. The available source are thousands. That's why, even though solar radiation have more intermediate nature, no guarantee how much energy is coming, hourly it is changing, then also we are dependent on solar, because only one energy is available in the world for needing for fulfilling our needs is solar energy. That's why we concentrate on solar energy. You can see the solar radiation kilowatt hour per meter square annual and Kashmir. And next, in south region also, in Andhra Pradesh, Chennai, Karnataka, somewhat it's a good solar radiation. The intensity scale you mentioned. So entire India is available solar radiation. The average solar radiation is per hour 5 per day 5.628 kilowatt hour per meter square area we can achieve that much of solar radiation. This is the sun nuclear reaction. The sun temperature is around 5,771 Kelvin. That much of radiation and temperature radiation energy, once it is reached to the earth, the temperatures are reaching up to maximum 50-55, and radiation 1353 watt per meter square of solar radiation is coming. This is a chemical composition, hydrogen, helium. This is the distance between sun and earth. Natural resource of radiation values, you see Different scientists given different value, but almost the value is 1353 to 1373. Generally, we are taking average value 1353. Maximum watt per meter square of solar radiation can reach to India, not India, reach to the Earth. This is the Earth orbit radiation variation, and based on the because Earth is moving self rotation and in axis rotation. Because of rotation of sun, so many angles are coming to the picture: latitude angle, longitude angle, hours angle, zenith angle. So based on declination angle, different angles are there. Because of angle of inclination, some of the energy is lost. I think from 1980s to 2010, more than 50 theses are produced based on just measurement of solar radiation, nothing else. Measurement of solar radiation or estimation of solar radiation with respect to latitude and longitude. That solar estimated solar radiation also, it may be beam radiation, not a global radiation. Or sometimes it is a global radiation, sometimes it is a beam radiation. More than 50 theses I know. IIT Roorkee or IIT Delhi or IIT Bombay majorly produced thesis just measurement of solar radiation or production of solar radiation. Different equations they developed, different unknowns, then validation of the equation. One of the model I am showing, because in our IIT Delhi, my senior did this validation. Finally, the measured value and predicted value almost came nearer value, not exact. Then this model somewhat it is useful for particular location only, Jaipur station, not all stations. This model is not valid for all stations. Then for production itself, we are doing this much of research means when we will develop the technology, that is the question mark. So developing technology, we are stopping for measurement of solar radiation. That's why establishment of lab is very much important. If your proper solar radiation measurement lab is available with you, then you can do some harvesting technologies, solar radiation harvesting technologies, and we can do evaluation, performance evaluation, and cost economics and feasibility study of the systems. If you don't have any system with us, any measurement of system, proper scientific measurement of system with us, then we are stopping up to just measurement of solar radiation only. The importance, just for the importance I shown, different measurement instruments are there. Pyranometer is there. This is the pyranometer for measurement of beam radiation, but this sensor always opposite to the sun. Then only it will generate the EMF. Otherwise, it will not generate the EMF. Pyranometer, upon the two bulbs or evacuated bulbs of there. Basic principle is just PNP junctions, two dissimilar metal junctions exposed to different temperatures. Automatically, it will generate the EMF. This is the tracking unit. Because opposite the sun, I want to maintain means every time one person will not sit and where is the sun, we can't search. So tracking system is required. This is the facility available in the institute, and logging facility. I will show that one. Next, temperature measurement, different measurement units are we are using. Second one, solar dryer facility, I already mentioned, industrial solar dryer with us. ETC with heat pipe collectors, collecting the solar radiation and storing that energy at storage tank. From that, we are supplying the hot fluid and air circulating inside the dryer cabin. Here we are heating and removal of the moisture is taking place in a conveyor belt drying system. This is the units: solar collector and thermal energy storage unit and dryer and damper unit and a full-fledged conveyor belt drying unit. Now, I think with this small introduction, what is the purpose? Measurement of solar radiation, and one established industrial dryer is available in our lab. In any participants from the Rayalaseema or Andhra region means they can visit anytime. There is no issue. Easily you can access. And also it is away from the class work. So anytime it is welcome for all participants. Next, I will show the instruments. This is the instrument. Now it is not opposite to the sun. Why? Because I am not given power supply to the tracker. This is the pyrolometer for measurement of beam radiation. Pyrolometer horizontal, upon the horizontal plane, how much solar radiation is coming. It is opposite to the sun, how much global radiation we are getting. Global radiation and beam radiation. Then we can calculate the diffused ray. Sun is that side, our system is this side. Why? Because I am not giving power to the tracker. Once I will start the supply to the electrical energy to the tracker, then automatically it will trace the sun first. You can see this is our institute buildings. So somewhat it is away from the main buildings. Because R&D, separate R&D center, we established solar R&D center. See, now also we are not given the power supply. Yes, now we given power supply. Then it is first tracking the sun. Where is sun? It is searching. This is the sensing unit. The sensing unit sensors giving equal amount of the EMF. Then only it will stop. Tracker will stop. Yes, dual axis tracking, multi-axis tracking, not dual axis. It is searching sun. Where is available? Yes. Let's see. Actually, dual arm system tracker we purchased. Measurement of global radiation opposite the sun, measurement of beam radiation. Global radiation, I already mentioned, maximum we will get to 1353 watt per meter square. Actually, there is no pollution, clear sky is available. Maximum beam radiation also we will get 1353 watt per meter square. Generally, due to the cloudy condition or pollution, the value may reduce. I will show the readings also. So now it is setting opposite to the sun. Almost 99.98% accuracy is there, tracker accuracy. Now you see data taker, I already mentioned data logging unit. It is capable to log per second basis. So high level intermediate nature also we can capture. Just the location we given RGM city. There see. First it is measuring the EMF, voltage content. And first one pyranometer 1053. Pyranometer it is showing only 655 only. And bulb temperature also it is giving. So 1000 is the beam radiation. It's not beam radiation, global radiation. Once 8 volts, 12 volts. 1057 watt per meter square is the global radiation. 653 the beam radiation. Around 350 watt per meter square is diffused when solar radiation reaching from the sun to the earth. 350 it is diffused. Two data loggers we are using. Upon the horizontal plane also you can see, because horizontal plane pyranometer we connected second data logger, because it is a dryer project. That one is only logging project. Two projects are 751. Upon opposite to the sun 1000. Upon the horizontal plane 757. Beam radiation 650. So three types of the measurement at the same place. I am not changing the place. That much of angle of inclinations are there. So my concentration, not measurement of solar radiation. That's why I procured the quality measuring equipments. If anyone developed any system, we are capable to do the performance evaluation and economic evaluation of the system. This is part of measurement of radiation. And second one, second video I will show. This one solar dryer unit. I will show solar dryer unit. Yes. This is the top view of the system. Just were checking the unit. Yes, ETC with heat pipe collector I mentioned. This is the heat pipe. Downside is evaporator part, top side is condenser part. By using aluminum foil support, we are placing in center. This evaporator part is placed in ETC tube and condenser part is placed in a manifold. You can see ETC tubes also, excess tubes we procured. Inside the tubes, I am immersing the this heat pipe by using the aluminum foil support for centering purpose. This is the collector unit. Total structure is fabricated by SS only. Because of SS, lightweight is coming. That's why grouting we did with the ground. This is a single manifold, contains 20 ETC tubes. 20 ETC tube contains 20 ETC heat pipe structures. Heat pipe immersed in manifold. 5 collectors in series to achieve the desired temperatures. The tube length is 1.8 meter. Diameter is 58 mm diameter. Let's see. 5 in series. Again, one more 5 in series. Total 10 collectors we collected. You can see. This is one more system, solar wastewater evaporating system. This is the second row of the collectors. You see some shading effect is coming. Unisol, it's a Gujarat-based company. They supplied. Because earlier I worked in Gujarat, so I have very good relation with the manufacturers. Entire system procured from the Gujarat suppliers only. You can see the heat pipe, how we immersed the manifold. So if any collector is failed, broken, our system will not stop. Our system will run by because fluid is not entering into the glass tubes. Fluid is circulating only in manifolds only. But all valves are manual valve control only we placed for R&D purpose. Once we reach the desired operating parameters, so we can do the automation. But this is for R&D. That's why every connection is manual by the valves only. Different loops I placed. One loop is directly goes to collector to the dryer chamber. Another loop collector to the storage tank. Another loop storage tank to the dryer chamber. 3 loops are there. According to the solar radiation availability, according to the demand conditions, the loops will change. This is the final connection is going to the drying unit. Drying unit is placed in first floor and total collector unit in top floor. And storage facility also I placed in first floor, top floor only. Only dryer unit and heat exchanger unit only available in the ground floor. Remaining everything is available in top floor. You can see the real working of the system. Some oil is leakaging. This is a common practice for industry. If any person visited industry means you can compare. If really working means some leakages are coming to the picture. If it is not working, very good, clean and green it will maintain. This is a flow measuring unit. How much flow rate is taking place? Yes, you can see. Yes, this is the circulating pumps. Two pumps standby also we placed. If one pump is failed, the second pump will come into the picture. From the tank, sucking from the tank and circulating through the collector, or circulating collector and dryer, or circulating directly to the dryer unit. This is the storage tank, 500 liters capacity storage tank. And electrical heater connection is there. If solar radiation is not available, we can give artificial heating of the fluid. This is the blower unit. Because after installing the system, construction of the shed takes place. This is the controlling unit, flow rate control and blower speed, variable speed drive unit we connected. Different velocities of air we can achieve, different velocity of the fluid speed we can achieve. Now the blower is running. So from that blower unit, duct is moving. You can see the duct is coming from the blower unit, and it is connected to the first floor dryer cabin. And from the first floor dryer cabin, exit is coming from first floor dryer cabin to the top. Here damper unit, we placed the damper unit. Yes. If we want to recycle the air, we will close this damper, exit damper, and we will open the intermediate damper. We will open the intermediate damper and we will close the inlet damper also. Then same air we can recirculate. If we want fresh air required, intermediate damper we will close and exit and inlet dampers we are opening. So different, I already mentioned, for energy saving purpose, bringing of the bonded moisture to the surface. We don't want fresh air. Same air we can circulate because based on the relative humidity. So intermediately we are measuring relative humidity and we are operating the dampers. This damper operation also manual only, because product to product is changing and seed to seed also changing. Chili I selected, different types of chilies are available. So seed to seed also, that removal of the bonded moisture to the surface is changing. That's why we kept manual operation only. Next, coming to the first floor, this is the dryer unit room. Fluid is coming from the hot storage tank and directly go to the dryer cabin, heat exchanger. From the blower unit, duct also connected to the heat exchanger. Fin tube heat exchanger we used like a radiator. You can see this is a system. This is the fin tube heat exchanger. So air is flowing through the fin tube heat exchanger, it is entering into the dryer cabin. This is a conveyor belt dryer. Babu, I need this dryer unit exit connection is connected to the total manifold, and same ducting unit is coming to the top side. Same ducting unit is coming top side. The feeding of the material. The feeding of the material is pouring from the top side. You can see white cotton cloth we used upon the conveyor belt because the material size we don't know. Different materials we are using. Mesh cloth, you can see. So air circulation will take place, but mass will available at surface of the conveyor only. Inlet and exit of the heat transfer fluid. So the lab, according to our convenient, we given the P&I connections. There is no rule and all according to availability of the space condition. Now our person started conveyor belt. The movement of the conveyor belt you can visualize. This is the outlet. Inlet is top side. Outlet is downside. This is the outlet. Because different materials, if after drying we are not cleaning the material, means later due to the overheats, melting of the material is taking place. Because this because of they are not cleaned after drying, whatever the residue material is there, that residue material melting is taking place. Yes. This is the conveyor belt unit. Hydraulic driven electrical motor for producing heavy torque, and this is the cleaning chamber. At present we are using, cleaning is not there, we will use as a storeroom also. Because movement of the conveyor belt is taking place. Here we are doing the loading operation. Yes, you can see full movement of the conveyor belt. But one major drawback, absorption of the heat is taking place by the conveyor belt itself. This is the loss. If cabin type, batch type system we are using, the absorption of heat is very less compared to conveyor belt system. But industry model demonstration purpose, we established this one. Compared to this conveyor belt system, batch type system will give the more efficient. I think This is the second lab. Thank you. Thank you very much for giving this opportunity. Now I am handing session to our coordinator.
So dear participants, so this is about the today's sessions. So tomorrow, so we'll have the session by Professor K. Arun Kumar. So he is going to deliver a talk on algae biomass resource for various energy conversion and production. So in the afternoon session by Narendra Singh, solar cells, ongoing trends and future challenges. So all of you join tomorrow at 10:30. So thank you for joining the session.